All right, so let's do some examples of calculating probability. Let's look at this situation right here. We've got, suppose that we have a bag of Skittles. Okay, a bag of Skittles. We know that there are, in a regular bag of Skittles, there are 5 colors of candy. There's red candies, orange candies, green candies, purple candies, and there's yellow candies, okay? And let's say this particular bag of Skittles has 9 red candies, 13 orange candies, 15 green candies, 12 purple candies, and 14 yellow candies, okay? And the question says, well, what is the probability of reaching into the bag without looking right after opening it? Right after, meaning you haven't taken any candies out of it yet at all. What's the probability of reaching into the bag without looking? You're not looking at what color you're getting. You're just reaching into the bag, taking a single candy, okay? Take out a single candy. What's the probability that that single candy will be green? Well, it's very simple. It's how many green candies there are out of how many total candies there are. So the first thing we need is how many total candies. Well, there's 9 plus 13 plus 15 plus 12 plus 14. 14, okay? Let's go ahead and get a calculator going. All right, so 9 plus 13, 9 plus 13 plus 15 plus 12, 15 plus 12 plus 14, 14, okay? All right, enter, and we get 63. So there are a total of 63 candies, okay? All right, great. All right, so we want to know the probability of grabbing a green candy. So here's how we would write it. We would write a capital P, and then we would open a parenthesis, and then we would write green equals. So this is saying the probability of a green candy. And the probability of a green candy is going to equal, well, it's how many green out of how many altogether. How many green are there? There's 15 green in the bag. So that's 15 over or divided by the total number, 63. So 15 out of 63. So we can either write the probability as 15 over 63. So if you want to be absolutely precise, you'll just simply write 15 divided by 63, and then you're done. But sometimes we do it as a decimal. So we'll do 15 divided by 63, and that gives us, all right, so here's how we're going to do it. We're going to go out to 3 decimal places here. We're going to call it 0.238. Now there are going to be times when we're going to go more than 3. We might go 0.238095. But for right now, we're just going to say 0.238, okay? So 0.238. So the probability of grabbing a green candy is 0.238. It's almost like saying a 23.8% chance, okay? All right, now let's try yellow. All right, well, the probability of grabbing a yellow candy is going to be equal to however many yellow candies there are. Well, there's 14 yellow candies. So it's going to be 14 out of the total number of candies, 63. So it's going to be 14 out of 63. We can do that as 14 divided by 63, and that's 0.222. All right, so that's 0.222, okay? How about the probability of getting an orange candy? Probability of orange. How many orange are there? There's 13 orange in this bag. Okay, so we're going to say 13 divided by 63. All right, and we can do that in a calculator. 13 divided by 63, and that is 0.206. So 0.206, okay? And then the probability of grabbing a red candy is going to be, how many reds are there? There's 9 red candies. So it's going to be 9 out of 63. And 9 out of 63, 9 divided by 63 is 0.14. Now look at this, 0.14 Now, there's a 2 here, but the 8, this 8 is going to tell you to move this 2 up to a 3. So we're going to say 0.143. So 0.143, okay? And lastly, the probability of a purple candy is going to be however many purples, how many? There were 12 purple, okay? And so we're going to say 12 out of 63. We'll do that in the calculator, 12 out of 63, and that's 0.190. There's a 4 here, so the 4 is not going to move the 0 up to a 1, so it's going to be 0.190, but we could just write 0.19 because we don't have to write the 0. So it's 0.19. Now if we add these up, we get 15 plus 14 plus 13 plus 9 plus 12 over 63. And so the probability of grabbing green or yellow or orange or red or purple. So we're saying or here. So we're going to add up all of the probabilities of all 5 of them is 1. It's 1. I'm definitely going to grab either a green or a yellow or an orange or a red or a purple because that's all that there is in the bag. Okay? All right, let's try a different example. All right, here's a sports example. Suppose an NBA basketball player has attempted 943 free throws in his career, and he's succeeded 775 of them. What's the probability that he will succeed in the next free throw that he attempts in the game? Okay, so what's the probability that he will make the shot? Make the shot, okay? Well, the probability is how many he's made before, 775, out of how many he's tried altogether, 943. And so we're going to do this in the calculator. 775 divided by 943. It's going to be 0.82, and this 1 will become a 2. This 8 will turn this 1 into a 2. So it's 0.822. 0.822. Well, now we can ask the question, well, what's the probability that he will miss? Well, there's only 2 possibilities. He either makes it or he misses it. Now, later on, we're going to see that this is called a binomial distribution, and we're not going to talk about that right now, but that's ultimately what it is. Basically, we can just do 1 minus the probability that he'll make it, which is 0.822, and therefore the probability that he will miss is 0.178, okay? 0.178. All right, let's try another one. Suppose the probability that John, let's say John goes to have a meal at a restaurant, and John, what's the probability that John will order a Sprite, suppose the probability that John will order a Sprite is 0.18. And the probability that he'll order a Coke is 0.39. Find the probability that he will order either a Sprite or a Coke. Well, we just add the 2 together. Probability of a Sprite is 0.18, so 0.18, plus the probability of ordering a Coke is 0.39. If we add those 2 together, we get 0.57. All right. And so the probability that he will order either a Sprite or a Coke is 0.57. But what's the probability that he will order not a Sprite and not a Coke? So something different than a Sprite or a Coke. Well, it's just going to be the rest of the probability, not 0.57. So it'll be 1 minus 0.57, which is 0.43. So I'll put 0.3. So there's a 0.57 chance that he will order a Sprite or a Coke, and there's a 0.43 chance that he will order not a Sprite and not a Coke. Let's just do maybe 1 or 2 more examples. All right, this is going to be our last example. This is what's called a discrete probability distribution, which we will discuss in Chapter 4. And what we have here is it's the probability distribution of an event happening in either January or February or March or April. Okay, here. So the probability of the month is shown right here. So the probability that this event will happen in January is 0.4. The probability of it happening in February is 0.1. The probability of it happening in March is 0.3. And the probability of it happening in April is 0.2. Now notice if we add all of these up, 0.4 plus 0.1 plus 0.3 plus 0.2 equals 1. Okay, so that's the total probability. There's only 4 months that it could possibly happen in, because when you add up all their probabilities, it equals 1. And what we want to know is, this is going to ask the question, what is the probability that it's going to happen in a month that includes winter? Well, January includes winter, so we're going to include that. February includes winter, so we're going to include that. March does include winter. In fact, March is mostly winter. March is 2/3 winter, and so we're going to include that. But April does not include winter at all, so we are not going to include April. So the probability of it happening in a winter month is going to be this probability plus this probability plus this probability. It's going to be 0.4 for January, plus 0.1 for February, plus 0.3 for March, and that's going to be equal to 0.8. So the probability of it happening in a winter month is 0.8. Another way to do that is, since April was the only one left out, we could have done 1 minus 0.2, which would give us 0.8, okay? All right, now what is the probability that it happens not in a spring month, okay? All right, well, let me clear out these check marks and X's. So, not a spring month, okay. So is January not a spring month? That's correct. January does not contain spring. How about February? Is February not a spring month? Well, it is not a spring month. It's all winter. February is completely winter, and therefore February does not include spring. Does March contain spring? It does. Part of March is spring, so we're going to leave that one out. Does April contain spring? It sure does. So we're going to leave April out as well. So we're only going to include January and February. And so the probability of January is 0.4, probability of February is 0.1, and therefore the total probability is 0.5. Okay? All right, let me erase these check marks and X's again. All right, so now we're going to ask, well, what's the probability of not January? Okay, well, is January not January? Nope. January is January, so we're going to leave that out. Is February not January? Yup. Is March not January? Yup. Is April not January? Yup. So we're going to include all 3 of these months. So we're going to do 0.1 plus 0.3 plus 0.2, and that's going to be 0.6. Okay. All right. Last one is the probability that it will be either February or April. Okay. So we're definitely going to include February. We're going to definitely include April, but we are not going to include January. We're going to not include March. We're only going to include February or April, so that's 0.1 plus 0.2, and therefore the probability is 0.3, okay? And so these are just some simple introductory examples of how we can answer probability problems.